In yesterday's lesson, we talked about the different properties of parallelograms. What we're going to be looking at today is learning how to look at a figure and determining if it is a parallelogram. And yesterday, remember we said that there are four properties of a parallelogram, right? Opposite sides must be congruent, opposite sides must be parallel, opposite angles must be congruent, and consecutive angles are supplementary, and the diagonals bisect each other. Remember, we went over all 5 of those properties yesterday. Now, for this particular lesson, what we're going to be looking at are ways to look at a figure and say, hey, is this a parallelogram or not? And you don't have to go through and verify every single property of a parallelogram. There's actually some shortcuts. And that's what this front part of this lesson is going to be looking at, is what are those shortcuts. So the first one, all you do is meet one of these 4 options, and you are automatically a parallelogram. So if I'm a quadrilateral, where I have a pair of sides that are both parallel and congruent, then that makes me a parallelogram. So you have to have the same side, the same pair of sides, and it both be parallel and congruent. Notice, I don't need to know anything else about the other sides. All I need to know is that these 2 sides are parallel and congruent, and that guarantees me to be a parallelogram. The next method is if I have both pairs of opposite sides are congruent. So this side and this side are congruent. This side and this side are congruent. So both pairs opposite sides are congruent. A third way, but you guys can guess what this one's going to be. Not quite there, Keanu. What do you think this one's going to involve? Diagonals. So what do you think we're going to be looking at with the diagonals? What was the property about diagonals with parallelograms?
That the diagonals must connect points that are both congruent.
Kind of. They bisect each other. So if my diagonals bisect each other.
That's close.
Yeah, you're pretty much saying the same thing.
You were just waiting for that thank you, weren't you?
And the last method is if both pairs opposite angles are congruent.
Oh, I haven't drawn the shape yet.
So if you match one of those 4, you are automatically a parallelogram. You just have to match one of those 4. Now, some of this homework today is going to feel like the same thing as yesterday's homework. And I remember doing this as a student, and it drove me nuts. Because I'm like, okay, it's a whole new lesson, but yet it's the same exact material. But what it is it's a fine word, fine print change is basically what it is. And you have to read the instructions. Yesterday you were told ABCD is a parallelogram. Go solve for X. What you're going to be asked to do today is find the value of X that makes ABCD a parallelogram. So you guys see that slight change. So we have to find values that will guarantee us that this will be a parallelogram. Yes, Gary?
So would all these factors work for, like, say, a rectangle, or a square, or a rhombus?
Since those are all parallelograms, yes. Now, this won't guarantee that, it won't guarantee that it's a rectangle, but it will guarantee you that it is a parallelogram. By the way, Here's a really easy proof. Let's go back up to here. If these are both parallel and congruent, how does that guarantee me that these two lines are going to be congruent? Well, let's draw the diagonal. Since these two lines are parallel, my diagonal acts as a, we call that line, a transversal. And remember we talked about the z? Anytime you have the z with parallel lines and a transversal, what do we have? Alternate interior angles. And what I actually have then, since the diagonals converge itself, as I have side, angle, side, congruent, so my two triangles are congruent. And since the two triangles are congruent, the corresponding parts must be congruent. Therefore, we get a parallelogram. Just bring some more stuff in there. Okay? Well, that's all we had to discuss today.